Yo, 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 yo! Hey, everybody. This is Mr. G, and we're going to talk about rate of change and slope. So, these are two things you guys are going to hear a lot about here coming up for this year and especially next year, especially when you guys are in algebra. These are pretty important concepts. So, we're going to take some time today to make sure that we get this down. So, two big key terms are rate of change and slope. So let's get those definitions down. Rate of change and slope, though, slope is rate of change. They are the same, but slope is more referring to a straight line, where rate of change could also be for lines that are not straight. Okay, so when we're talking about rate of change and slope, we're talking about ratios. Okay, key terms, so fractions. Ratios of the amount of change in the y variable to the amount of change in the x variable. So we're going to have a fraction with the amount of change in y and the amount of change in x. Slope is the same thing. It's the amount of change in the y and the amount of change in the x. Slope is another term we use is rise over run, and I want to look at that here in just a second. So just know with rate of change and slope, we are talking about fractions. Now, for rate of change and slope, this is your formulas that you guys can write down. I know this isn't included, so make sure you get this down. Put a big star next to it. Rate of change is equal to change in y over change in x. That's what we just talked about in the definition. So we're figuring out what is our amount of change in y. That is in our numerator. What is our amount of change in x? That is our denominator. Very similar to when we found unit rate. And unit rate was just y divided by x. Or we determined something was proportional. We did y divided by x. Same situation, but now it's change in y over change in x. Another way when looking at a graph is rise over run. This rise means change in y over change in x. Run means change in x. Okay, so I'm sorry, rise means change in y, and run means change in x. So what I mean by that is if we're looking at a graph, if I have a straight line here, what we want to find out is what is the slope of this line. So if I'm looking at what is the slope of the line, when we say change in y, well, here's all my y values going up and down right here. So the change in y would be, if I'm looking at this point to this point, my change in y is what's the rise. So there's my rise. And then that's how much I change from y going up and down. And then my run would be the change in x. So we got somebody talking to us. We're all good. Okay. So rise over run, change in y over change in x. Oh, they came back again. And now, let's look at what we're talking about, though, and how this is going to be used in practice. So first, you're going to have tables, and you also might have graphs. So if we have tables, and we want to determine what the rate of change is, or we also might want to determine if the rate of change is constant or if it is variable, what we need to do is we need to calculate the rate of change by doing change in y over change in x. So change in y over change in x. Okay. So what we're seeing is by doing change in y, I'm saying, okay, well, how much did my y change from here to here? Because remember, x's are always on top, y's are always on the bottom. So how much did my y's change from 15 to 45? Well, I went up 30, so that's positive 30. I think the change wasn't down, it went up. Change in x's, up 2. So I'm going to set that as my ratio. 30 over 2 is equal to 15 over 1. So that means the change was $15 per one ln, because dollars are the y values, lns are the x values. I want to see, is the rate of change constant? So is that this continuing? Is that what it does from here to here as well? So my change in y was 45. My change in x was 3. 45 over 3 is 15 over 1. So far the rate of change is constant. Now, let's look at the last one. Up 30, up 2. And we know 30 over 2, we've already had that rate of change, is 15 over 1. So the rate of change is constant. So that means the rate of change is constant, and the rate of change is 15 over 1. Change in y over change in x. Now, some of you are saying, well, Mr. G, we could have just done y over x, 15 divided by 1 to get 15, 45 divided by 3, 90 divided by 6, 120 divided by 8. And that is true for this case because that shows that it is a proportional relationship. The thing is that sometimes if it's not a proportional relationship, it can still have a constant rate of change. So that's why it is super important that we actually check the change in y and the change in x and not just do y divided by x. Okay. That is how we find the rate of change by looking at a table. We're just checking the change in y's, comparing it with the change in x from those two values. Now, by looking at a graph, this is when we're going to consider rate of change more as slope. So when we look at tables, this is when we really call it rate of change. When we look at a graph, though, this is when we call it slope. They do mean the same thing. It's just how we refer to it. Okay, let me make this a little bit bigger for you guys. So, and then I'm going to erase the rest of this just so we got space. Now, if I'm finding the slope of a line, right? We say slope, you guys. It's called slope because slope, think of it going to the ski slopes. If you've ever gone skiing, if you've ever heard of the ski slopes or ski resort known as the slopes, it's because they're hills. And hills all have slopes. So that means some hills are steeper than other hills. So these are all lines that have slopes because they have different steepness. Okay? The less steep a line is, or the more steep a line is determined by what its slope is. And that's how they determine ratings at the ski slopes. If it's super steep, like this one right here, then that might be like a black diamond. If it's not quite as steep, that might be a blue square. And if it's really flat, then that would be the green circle. And that's only for if you guys know what I'm talking about with skiing. If you have no idea what I'm talking about because you've never been skiing, don't worry about that. So slope is really just a steep, it's really just the steepness of the line. So the way we find slope is we do change in y over change in x. But change in y over change in x is just rise over run. Okay, that's just a shortcut way of remembering it. Because the rise is how much you're going up and down between 2 points. So here I have a point, here I have a point. So if I want to see what's the change, and we always read left to right. Left to right. Okay. But if I want to know, well, what's my change between here to here, or from here to here, I guess it technically doesn't really matter. But my rise, I'm going up from here to here. This y value started down here and went up 1, 2. So that's why my rise equals 2. And then the run is going left to right. 1, 2, 3. So the run is 3. But the run went in a negative direction, so that's why it's negative 3, giving me a slope of negative 2/3. And I am done. So the slope would be negative 2/3. And the reason why, another way we know it's a negative slope is because if we look at this line from left to right, it's going downhill. If I start on the left side of the line, I work my way to the right, I'm going down, not up. So you can always trace it and figure out from left to right and figure out if you're going up or down. If you're going up, it's positive. If you're going down, it's negative. We're going to practice a couple more of these because I know it could be a little bit confusing. So I have another table and another graph that we're going to find the rate of change in the slope of. Okay, so we talk about the approximate height of a football after it is kicked. Tell whether the rates of change are constant or variable. Find the rate of change. So, same thing. So here, x is always, if we have a horizontal vertical table like so, x is always on the left. So this would be my x. Y is always on the right. So that's important to know. So what I'm doing is I'm looking for the change in y and the change in x. So I'm comparing what's my change in y. So change in y over change in x. Okay, so what's my change in y here? Well, I go up 18. And then what's my change in x? I go up 1/2. So that would be 18 over 1/2. Well, to get, what I would do here is I would multiply by 2 to figure out what it is to 1. And that would be 36 over 1. Because 1/2 times 2 is 1. So now I'm going to do the same thing again and see if I have the constant rate of change. Because if it's constant, I'm going to get 36 over 1 each time. So here I went up 13, and I went up 1. So 13 over 1, two different rates of change, so it's not constant, which means it is variable. So that means this graph, if I were to actually plot these points on a graph, it is not going to give me a straight line. Because a straight line has a constant rate of change. So that won't work. Instead, it's probably going to be some type of curve. Okay, and that makes sense because if you think about it, when you kick a football, it's going to go up fast at first, and it's going to slow down, and then it's going to start coming back faster down again. So that is the shape of the graph, and it's not going to be a constant rate of change. It's variable, which means it's changing its pace. Okay, so it's not going to make a straight line. So the rates of change would have been 36 over 1, 13 over 1. You could also still, if it wanted you to figure out all the rates of change to prove it, this one went down 5, and then it went up 0.5. So now I'm at negative 5 over 0.5, which is negative 10 over 1. And that shows that downward when the football starts coming down. That's why it's a negative number. Okay, so there's all those rates of change. Now, if we were looking at the slope, I know you don't have this graph in your note taker, but maybe try to do a quick sketch and just try to get these two perfect points. You don't have to have the whole entire graph, but I want you to have this point at negative 2, positive 3, and I want you to have this point 3, what is that, positive 6, okay? Because we're, again, finding the slope by looking at a graph, which is so important, okay? So let me make this a little bit bigger for you. Okay. Now, so if I'm finding the slope, I'm looking at a rise over run. So I'm looking at the rise over the run, and really I'm looking at rise over run. Whoops, that's not the pen. There we go. I'm looking at rise over run, and I'm doing this with 2 perfect points. And luckily this gave me 2 perfect points. I have a perfect point here, and I have a perfect point here. So I want to figure out what's the rise from here to here. So what's my change in y from 3 to 6, and then what's my change in x, which is known as the run. Because we run left and right, we rise up and down. So one thing you can do with your pencil and a paper is you can count. 1, 2, 3. So my rise, I went up 3. Then my run, I go, from here, 1, 2, 3, 4. My run, I went to the right 4, and right is positive. So that means my slope for this line is positive 3/4. That's the change in y over the change in x. And we know it's a positive slope because if I trace this line from left to right, my pencil is going up. So therefore, it's a positive slope. It's going uphill. The rise went up 3. The run went over 4. Okay. So a couple things to remember. Use a slope formula to find the slope between 2 points. That slope formula is change in y over change in x. If we have a rate of change of a relationship that is constant, it does create a straight line, which means we have the same slope. We have the same slope each and every single time between any 2 points on that line. So what that means is, let me go back to this graph right here. If I continue to do this slope, it would continue to work on any points on this line. So if I found another perfect point, if I go down 3, 1, 2, 3, over 4, 1, 2, 3, 4, look, I'm back on the line. That slope works every single time, no matter what, over. So 1, 2, 3, 4, 1, 2, 3. No matter how I use my rise over my run, it's still going to take me since 1, 2, 3, 4, 1, 2, 3. So I'm going over 4, I'm going over 3, I went over 4, I went over 3. No matter what, the slope maintains the same because it's a constant rate of change, and slope is the rate of change. So that's another thing to remember. If we need to write slope equals rise over run in our things to remember, I would do that because that is so important. Write change in y over change in x as well. Okay, and then that'll get you set up to hopefully be successful later on. So hopefully this helped. Make sure you get the independent practice done. We'll talk about it together. And if you guys have any questions, do not hesitate to ask me. All right, Gradius out.